3.
Hey everyone, welcome to Math for Teachers, Module 5, Chapter 7. My name is Robin Surf.
I'm Maria Segura Bolaños.
And I'm Patricia Montgomery.
And this is our Chapter 7 presentation. Patricia, how do you know what power of 10 to multiply by?
So what you're going to do is you're going to look at how many places away from the decimal you need to go in order to get to the end of that number. So for this number, you have to go over 6 places, and so you're just going to add 6 zeros to a 1, and then you're going to multiply by that in order to get your number. So if there was 2 decimal places, you'd have 2 zeros, or so on from there.
Okay.
Perfect.
Awesome. All right.
So Robin, are you able to convert the decimal below into a fraction?
Okay, well, let's go ahead and take a look at the decimal 0.225. The first thing to notice is that there are 3 decimal places behind the 0. So let's make this easier to work with and multiply 0.225 by 1,000. And when you multiply 0.225 by 1,000, you will get 225. We are really not changing much here because 1,000 over 1,000 is actually 1, but if we multiply it this way, we can now write the first part of our fraction as 225 over 1,000. But we know this can reduce down much more, and once you can do that, the final answer will be 9 over 40.
Awesome.
Nice.
Okay.
Okay, Maria, this question is for you. How would you find the GCM of the denominator 36 and 54 in order to convert to a decimal?
Well, first you're going to take your 36 and your 54, and we're going to basically use your prime factorization. And let's see, let me get my little pen up here. So for 36, we're going to start out with 4 and 9, which is going to give us 2 and 2, and then over here 3 and 3. Then the same thing for our 54. We're going to go over to 6 times 9 is 54. We're going to break that down to 2 and 3, and then our 9 goes down to 3 times 3. So if you look, the most common things that we see, the 2 common factors are 2, 3, and 3 here. We've got 2, 3, and 3 there. Those are the common things. So when you actually, whoops, I went ahead of us. So when you actually, well, come on. All right, so then when you take the 2 times 3 times 3, you're going to come out to an answer of 18 for your greatest common multiple, because those are the 3 digits that are common with both the prime factorizations for both of those numbers.
Okay,
Awesome.
well, thanks for showing your work.
Yeah. Robin, are you able to understand why the below graph has its shape?
Well, for this particular question, I would like to know if anyone can understand why the graph I'm about to show you might look the way they do when given a formula for the equation of that graph. So let's go ahead and look. In looking at x divided by 2, the slope is actually 1 over 2. So you can actually say that for every 1 male born in the US, there are 2 females. That is why the line slopes at an angle. So if you notice on the x-axis, every time you move over 1 unit, the units on the y-axis will move up about 2 places. So you can see how for every 1 male, there are 2 females, the graph will actually slope upward in that direction.
Okay, very good visual.
That's cool. Yeah.
Yeah, thanks.
Hey, Patricia, how do you find the slope of a line?
So, like what Robin was just showing you, whenever you have an equation for a line, so y equals kx, you know that the y and the x are our axis points, and so you want to know what that slope is going to be in order to know what rate of change your line is going to have. So when we have the y equals x over 2, we pull that number out in the front, and that's our slope, which is 1/2. So we know how our line is going to be moving.
Okay.
Awesome. Okay, Maria, can you create a graph using the table below the formula y equals x over 2?
Sure. So our question is going to be, Buddy the Elf is selling Christmas cookies at $2 each. How many cookies can I get with $10? So we're going to use the formula y equals x over 2. So we have our axis up here is going to be our actual Christmas cookies. That's going to be our how much we are making. And then we have our, wait a minute, I said that wrong. We have our x-axis over here, or our other axis over here. All right, so basically I have $10. So I have marked out, I've actually went through and marked out everything from 2 all the way up to $10 worth of cookies. So when you take your x and y axis where the point to meet, you're going to look over and you're going to have 5 cookies that you can buy with $10. So
Awesome.
Perfect.
I like your animation too.
who doesn't like cookies?
I used cookies too.
Robin, what is the percentage and fraction of the figure below?
Well, this particular picture is actually called a yin yang. Although the lines are in the shape of a circle, we can safely assume that the black portion takes up half of the circle. So how this is written, we write this as 1 over 2, otherwise known as 1/2 or 50%.
Awesome.
Perfect.
Thanks.
Hey, Patricia, how do you determine the percentage of something based on a picture?
So what we're going to do is we're going to take our shaded part and we're going to see how many pieces of that would fit into our picture. And so if we kind of broke up those bigger triangles into smaller ones like the shaded piece, we would get 8. And that's going to be our bottom number of our fraction. And then how many of those parts that are shaded, which is 1, is going to be that top part. So 1 of our 8 pieces are shaded. And so if we're trying to put that over into a percentage, we do percent in 100. So you're just going to multiply it by 100 and you would get 12.5 or 12.5%.
Okay, awesome.
Very good.
Thank you.
We'll go over here.
Okay, Maria, this question is for you. Can you show us a figure representing the fraction 4 over 8?
Yes, I sure can. So actually I have 2 figures here. If you notice, they both have 8 pieces made out of them. However, one of them has 8 equal pieces, the other one has 8 unequal pieces. So for us to correctly make this picture, we have to make sure that our figure has equal pieces, or else it doesn't count. It will be wrong. So it'll be our purple one, because over here we do have the 8 equal pieces of pie, and then we're going to shade in 4 of them. So we'll take, I put my emoji up there a little too soon, but we'll shade in the bottom 4 over here. So we've got 1, 2, 3, 4. So that would be the correct diagram for 4 over 8. This one is wrong. We wouldn't use that one at all.
Don't want to get gypped on your pieces of pie.
Absolutely
You have
not.
the hexagon below is the as our whole piece.
Okay, so basically what this question is asking us, how many triangles fit inside the hexagon. So what we can do is use lines to divide the hexagon into 6 equal parts. Now that the hexagon has been divided into 6 triangles, then we know that one of those triangles will be 1 out of 6 or 1/6. When you work your decimal conversion, this is 17% of the hexagon.
Okay. Pretty good.
Perfect.
Thanks.
Nice.
Hey, Patricia, can you match the pieces below with their percentage?
Yes. So like what Robin was just showing us, we have this hexagon is a 100% because it's completely whole. And then we want to see of the trapezoid and the rhombus, which percentage of that whole they are. So basically, trying to see how many of that shape, like the trapezoid would fit twice into our whole piece. That would be 100 divided by 2, which is 50. So we know it's 50% of our shape. And then for the blue rhombus, it looks like it'll fit about 3 times. And if you divide 100 by 3, you get 33.3, which is the percentage.
Awesome. It's interesting to know those shapes will actually fit into that one.
Yes.
All right, Maria, if the grid below has 50 total squares, what is the percent of shaded in squares?
Well, first we're going to count. We know that the entire grid has 50 squares total. So our shaded squares, we've got 6 shaded squares on each corner, and there's 4 corners. So we'll take 4 times 6, and then we have 2 on the top and 2 on the bottom, so 4 more. So we'll do 6 times 4 plus another 4. It gives us 28 total shaded squares. So then we're going to take 28 and divide that by 50, which is the total amount of squares we have. That equals 56. Then we would actually multiply that 56 by 100 to give us our decimal point or our percentage, which would bring us over to 56%.
Okay, that makes sense.
Nice. Robin, are you able to interpret the percentage problem below?
Okay, well, let's go ahead and look. So David gave 75% of his cookies to Sam, and Sam received 3 cookies. So how many cookies did David start with? Well, what they're asking is if Sam was given 3 cookies, how many cookies must there have been if he was given 75% of them? So we can see in the picture that 3 cookies equals 75% of what? This refers to the last scenario where we know that each cookie must be 25% since there are 4 of them. And if Sam took 75% of the cookies, he had to have taken 3 of them. So that means he took 3 out of 4 cookies. So 3 cookies equals 75% of 4 cookies.
Awesome.
A lot of cookies.
Yes, I want a cookie now.
I know.
I gave the class, hey Patricia, I gave the class 25% of this week's assignments today, and they received 2 assignments. How many total assignments are we having this week?
So if the class has received 25% of their assignments and they've had 2, then we know that 25% 4 times would give us like our whole number. So, or we could do 25 divided by 100, which is going to be a 4th if we reduce the fraction. And so 2 times 4 is going to give us a total of 8 assignments. So we'll have 8 assignments this week.
Awesome.
All right, Maria, this question is for you. If I have 8 lollipops total and share 3 with me, Robin, what percentage of lollipops did I give away?
Well, we have, over here we've got our 8 lollipops. We're going to give away 3. So there's going to come over here to Robin's side. She's got her 3 lollipops. So now that leaves me with 5 on my side and 3 on her side. But the total is going to be, we had 8 total. So we would take 3 divided by 8. That'll give us actually 3.75 as a decimal point. And then to get to that percentage, we have to multiply that again by 100. And that would give us 37.5% of those were given to you, Robin.
Woohoo! Thank you.
And sharing is caring, so we used our hearts. And Robin is
And
excited.
I like lollipops.
Oh.
There's me. All right. And Maria, if I have a recipe for 16 servings, but I need to serve 10 people, what formula would I use to find the proportional change needed for my recipe?
Well, you're basically going to use the simple formula of using the desired serving size that you need divided by the recipe serving size, so whatever your recipe calls for. Then you're going to multiply that by the ingredient amount in the recipe. So for example,
Okay.
I've got half a cup of flour for 16 servings. So my desired serving size is actually going to be 10, because I want to serve 10 people. I'm going to put that on the top. The recipe actually calls for servings of, it'll give you 16 servings. So take 10 divided by 16 is going to come out to 5/8. Then I'm going to multiply that by half a cup, because it tells me in the recipe that half a cup gives us 16 servings. And that's going to bring us down to 5/16 of a cup of flour for a recipe for 10 people.
Okay, that makes sense.
Perfect.
So Patricia, I'm going to make cookies for a potluck with 30 people. The cookie recipe I have is only for 15 people. How do I double my recipe?
All right, so kind of like you just had to reduce yours, I'm going to try to make mine bigger. So we're going to multiply it. Since we have half as many people in one batch as what we need, we're just going to multiply our recipe by 2. So for the sugar, we need half a cup for 15. So if we multiply that, we get 2 half cups, or 2/2, which then is just 1 full cup of sugar.
Okay.
And then the eggs, 1 times 2 is 2, which we know. And then the 3/4 was a little bit trickier. When you multiply it by 2, you're going to get 6/4, which you can either then, individually do those 6 1/4, or you could do the 3/4 twice, or you could just do a full cup and then half a cup. So there's a lot of ways you can kind of go about that one, but 6/4.
That's cool. I liked how you showed your work.
Absolutely. All these recipes for cookies are making me hungry.
What about some oatmeal?
So if we have, let's see, how many cups of flour do you need for 4 cups of oatmeal?
Okay, so a recipe for oatmeal cookies calls for 2 cups of flour for every 3 cups of oatmeal. So how much flour is needed if you have 6 cups of oatmeal? The first thing we know is that we need 2 cups of flour for every 3 cups of oatmeal. So what we can figure out from this, if I divide 2 by 2, that will give me 1. And since I divided 2 cups of flour by 2, I also need to divide the 3 cups of oatmeal by 2. And 3/2 is actually equal to 1.5. So now that I know 1 cup of flour equals 1.5 cups of oatmeal, I can simply just multiply any number of cups by 1.5 to see how many cups of oatmeal I need. When I multiply 4 by 1.5, I get 6. So I need 4 cups of flour for 6 cups of oatmeal.
Awesome.
Nice.
I like it. All right, guys, that concludes our module 5 video. Thank you.
Thank you for joining us.
Bye.
Perfect timing.